So I've gone to page 41 of the first lecture 1 of the notes, and there's a piece of code that really encompasses all of the stuff which has gone before. So you've got 20-30 pages of material, but it really all sort of comes to fruition on this piece of code here. Now you remember from before that what we had is we needed to create a .c file, and this one here is called dweight.c, or that's the labelling across the top there. So similar to before, this is the videos we're recording, by the way. I'm going to go to my documents file, I'm going to go to my C code. Now we've exhausted hello.c, but I want a new file in there called dweight. Well, the way I'm going to do that is I'm going to say I want a new text file. There are other ways of doing this, but I'm happy to do it this way. Dweight, and I'm just going to click away. Now you can see dweight is a text document, it says so here. So I'm going to open that up, and I'm just going to do File, Save As, and it's now dweight, but I'm going to go down here where it says Text Document, take the drop down, click on All Files, and I'm just going to put .c in here, and then save. And then you should see in here I've got 2 dweights. I've got one .c, and it says, look, C file. And this one here is a text file. Well, I don't want that, it's just taking up my hard drive, so I'll delete that one. Okay, so I should now have dweight.c. That's a major step forward, so just going to minimise that now. Now remember before, we cut and pasted before, and we ran into a few problems, so we've got to watch those double quotes because they don't cut and paste across very cleanly. But I'm still too lazy to type all this out, so don't forget the last curly brace. Do Control C for copy, and I'm going to plonk that in to Notepad here. Now I'm just going to do a quick scan because once bitten, twice shy. It would appear the double quotes seem to have copied across quite well here, so I'm happy with that, and I'm going to save that. I'm just going to pass you over to Mike now, who's going to do the build part of it, if he's happy with the code, although something doesn't look right about that code, Mike. What do you think?
No, it doesn't look right because of the formatting. I mean, we normally...
Well, first of all, on that first line, what's this / star
yeah,
/ I don't like that at all.
This is for block comments.
Ah,
so
okay.
what this does is / star starts an area of block comments, and we can put as many comments as we want with as many new lines in until it sees a star /
Okay,
so it's got to have the start and the stop of a block comment.
Yeah, yeah.
So in this case, I mean, we can just reduce that down a little bit and make that look a bit nicer for ourselves, like so. And then maybe we can.
Yeah, that's much better.
You know, just make it look.
So it's going to ignore that first line. We know what standard IO or stdio, and you're doing what I would do, I think now, which is tabbing it in, not because you have to tab it in, but just because it looks better, doesn't it?
Yeah, this is just a problem from copying and pasting.
Yeah.
And I'm just going to make everything line up.
That looks much more readable. So remember from the previous example, so we've included the standard io.h, that's because we need to use the formatted printf statement, isn't it?
Yep, exactly that. We're using the printf library statement. What we're doing is we're declaring some variables of type integer. We've got 5
Well, hang on, before then, so we've got our int main.
Yep.
So that int main is encompassing all of the code that are between those curly brackets. So that's what int main is. It's all of this code in here. Fine, fine.
So we declare some variables. We
type integer.
Type int.
Now I'm not used to this either because it says int height, but it doesn't tell me what length, width, volume, and weight.
No, you can't. You need to initialize the variables afterwards. So what we're doing here is all this is really doing is reserving a space in.
Yeah, but it doesn't say what length is. Why doesn't it say int length, int width?
Because we're using this comma.
Okay.
We're using this comma, and that can separate. So when we want to declare multiple variables, we can add them in line with a comma. It's also perfectly valid to do this. To do it like this, as long as we include this colon.
Yep.
This is perfectly invalid as well. Yeah, so we can.
Perfectly valid.
We can
So yeah, let's do it that way, just to be different.
Here we are assigning some initial values to the variables. As you can see, height is going to
So
be
why is that
something
important to initialize things? Why can't I just
because
use them?
in C, and this is a very good question, in C, any variable that's declared is uninitialized, right? Which means it can have an unknown value. It
So
will not have
inside the
zero.
computer, the registers, which is the ones and zeros, that could effectively start in a random state.
Yep. So with my int height here, if int is a 4-byte number, for example, it could actually start. If I didn't initialize it to 8, which is happening here, the value of that to start with could be 1,246,743. I have no idea what it will be.
Okay, so even if you want it to be 0, you've got to tell it that
Yes,
it's 0.
exactly. In fact, what we have here is some uninitialized variables. We're only initializing 3 of them: height, length, and width. Height, length, and width. We also have volume and weight. But as you can see, volume and weight are being initialized before they've been used.
Yeah.
So it doesn't matter. Yeah, because volume has been initialized with a calculation.
So that's the first time it's actually used
Yes.
for anything constructive, as
Yes.
you're just assigning it with a value.
Yes.
So that's effectively initializing it, isn't it?
Absolutely. In fact, if I didn't initialize it, I would get a warning from the compiler to
Mm.
say that I am using an uninitialized variable.
Mm.
So here we're initializing the variables, and volume and weight are being initialized with a calculation based on these previous variables. So volume will obtain the result of height 8 times length 12 times width 10,
Okay.
and the result will be stored in volume. And in weight will be these normal brackets here, parentheses. They denote the order of precedence. So as you can see here, we have an addition and a division. What will happen is the addition will happen first because it's contained in these brackets. So the compiler will take volume, add 165 to it, take that result, and then divide that result by 166. That's the idea behind these parentheses. If I don't put that there, then what happens is it falls back to the natural parentheses and order of precedence rules of C, and they can get quite complicated. It's much better to make it very clear by adding these brackets.
So just doing some maths, put your brackets in the right place.
Yeah.
To be sure it's doing the processing in the order you want it to.
Now the printf statements have got a little bit more complicated down here. As you can see, the complication are these parts just here. You can see I have a %d, x, %d, x, %d. %d, as mentioned in the lecture notes, will display a variable in integer form. And the variable, what this is what's called a formatting placeholder. So if I put a %d or any other % character in there, I need to add a variable on the end.
So that %d is the injection point of where that variable is going to be inside the string.
Exactly.
That's clever.
And it is in this order as well. So if I have 3 injection points, as you say, with the percentages, I need to also have 3 variables. If I don't, I will get a compiler error.
Okay.
So in this case, the first %d will get the first variable. The second %d will get the second variable. The third %d will get the third. So the value that length variable is containing will be replaced and put here. So this %d will not be printed. Instead, it will print the value held in the length variable. Yeah? And this second %d will print the value held in the width variable, and so on. This \n, that forces a new line in the end. So
Yeah,
the
I saw
cursor
that in the notes earlier. So that means that line will be printed out, and then the next piece of printing will be on another line.
second line, yeah, it's like pressing the return button.
Yeah.
Okay, so the same goes for these next 2 printf statements. They just print in one variable. With the
There's
%d.
volume there. Yeah.
So I have 1% %d, I have one variable.
And
I have
pressing the
3
new line
%d.
button afterwards. Yeah.
Yep, and this x here is just printing a character x. It's just printing the character x, as we'll see in this.
Fine.
So make sure this is saved. Let's pop along to our command prompt, and we're in the correct directory, my C code. So what we can do now is we can type gcc, and I want the output file to be called, let's call it dweight, D-W-E-I-G-H-T. Yeah.
Yeah.
And
that would be dweight.exe, but we don't need to
we don't need to add the exe. And
Yeah.
now I want to compile dweight.c, the file that I have just created, and say dweight.c. Yes?
Yeah.
So I press enter on that. I I have no
That's
errors.
successful, isn't
That's
it?
great.
Yeah.
So now if I list the contents of my directory, I can see now that I have a dweight.exe.
Yeah.
So let's run that.
No, you just ran the dweight.exe.
Sorry, very well pointed out. Let's run dweight.exe.
No, you don't need the exe, you told me.
Yeah, I don't, but if I don't, it's gonna, yeah, there we go. There we go. So we have, what we can see is dimensions in a printf statement, dimensions, %dx, %dx, %dx
Yeah,
evaluates
gotcha.
to 12, x, 10, x, 8.
Yeah.
And then everything else is as expected. It's just maybe one interesting thing. Let's say that I have another %d on the end of here, yeah?
Okay, so now the
just
number
we'll
that
just
we're
add
asking
another.
it to print isn't going to match
Yes, so I've
the
got,
number of things that we have there.
it's expecting 4 variables to be printed,
Yep.
but I'm only giving it 3.
Okay,
Let's see what happens when I save and compile that.
did you save it?
Yes. Maybe I didn't. Let's try it. It's interesting, isn't it? That might be because it's on the end. Let's actually run it. See what it does. What it's done there, you can see now I have a runtime error. It's actually used the last variable twice.
So it is.
So it's actually not giving me a warning. Some C compilers do give you a warning on that, but in this case it has not. But it's used the last variable in there twice. So I have had an error. It has shown me an error.
Okay, so indulge me, I'm just going to take that last one that you've done there now. So we've obviously got 4 placeholders or injection points or whatever you want to call them here, but we've only got 3 variables here. So what I want to do in the last one is I want to put 1 million. Okay, so I'm going to do what you did just now, so I'm going to try and compile that using the up arrow because I'm lazy. That looks right. And run dweight. And there it is. So I've got 12 times 10 times 8 times, and then there's that million I stuck in the end there. Yeah, so I'm happy that piece of code is running. Excellent.
One other thing that's just quickly worth checking is let's try an uninitialized variable. Let's comment out and let's take away this height equals 8. So now what we're going to do is we're going to do a multiplication on something that's not been initialized.
So it doesn't exist.
It doesn't exist. So what's it going to do? Is it going to be a 0? Is it going to be something else? Let's run it. Let's actually compile it and see if I get a warning. I get no warnings. Now there may be a switch where I can turn on those warnings. Yeah? But in this case, now I'm going to run my program. Let's look at it up there. Here we go. Right. And now, in this case, it's initialized it to 0.
And clearly that's not the right answer, is it?
No, clearly this is not the right answer that we expect. But that gives you an idea that we're very lucky in this terms that it has initialized that to 0 for us, but that we cannot assume that that's going to happen.
So you must initialize all variables before you use them, because otherwise the output can be not very, take the million can be not very well defined, so you don't actually know what it's going to be prior to running that piece of code.
Exactly.
Okay, just get that up and running again. And there it is.
It's